Hi guys, this is lesson 2 in unit 8. We're going to talk about solving quadratics by factoring. Before we start solving, we need to talk about the zero product property, which is one of the properties of real numbers that we did not talk about in the past. When we have two or more terms with a product of zero, that means that at least one of them is equal to zero. So if we have x times y equals 0, then either x is equal to 0 or y is equal to 0, or both are equal to 0. The solutions are also called the roots, the zeros, the x-intercepts. Let's take a look at our first example. We have 3x equals 0, and we're trying to solve for x. We know that when we have 3x equal to 0, that means that either 3 is equal to 0, which is the first factor, or the second factor is equal to 0. And since 3 equal to 0 is not a true statement, we have to reject this answer and accept that we have one answer, which is x equal to 0. Second example, we have x times x minus 1 equal to 0, which means that we have two factors multiplied by each other and their product is 0. That means it's either the first factor x is equal to 0 or the second factor, which is x minus 1 equal to 0, or both are equal to 0. So I'm going to solve this quadratic. The first one is solved, x equal to 0, and the second one I need to solve by adding 1 to both sides, and I'm going to end up with x equals 1. So we have two solutions. We have x equals 1 and x equals 0. Two solutions, two roots, two x-intercepts. Now let's take a look at this example where we have x plus 1 times x minus 2 equals 0. Again, we have two factors, x plus 1 and a second factor, x minus 2, and their product is 0. And based on the zero product property, this means that either the first factor, x plus 1, is equal to 0, or the second factor, which is x minus 2, equal to 0. So to be able to find the solution for this quadratic, I'm going to have to take away 1 from the first equation to help me solve it for x, and I'm going to get x equals -1. I'm going to solve the second equation by adding 2 to both sides, and I'm going to get x equals 2. Two solutions, two roots, two x-intercepts, which is -1 and 2. Let's take a look at example number 4. We have x squared minus 7x equals 0. This is a quadratic equation that we're trying to solve for x, and we're using factoring as a method to solve this quadratic. So the first thing that I have to do is to factor this quadratic. I know by looking at this equation that I can use GCF to be able to factor this quadratic. The GCF in this case is x. Both terms have a greatest common factor of x. That means I can end up with x times x minus 7 equals 0. Now I have two factors multiply by each other and both are equal. Or their product is equal to 0. This means that I can have the first factor equal to 0, and then the second factor equal to 0, and solve both equations. The first equation is solved for us. We have x equals 0. That's the first 0. And the second one, I can solve by adding 7 to both sides. And when I add 7 to both sides, I end up with x equals 7. So for this equation, we have two solutions. We have x equals 0 and x equals 7. Both make the quadratic equation a true statement. and both are also called the roots, the x-intercepts, and the solutions. Answers are correct or not by putting the quadratic equation in y equals. So in this case, I'm going to put y equals x squared minus 7x. I know that my equation is equal to 0. That means I need to look at the table and find out what the zeros are, or the intercepts are. So in this case, you'll see that when x equal to 0, the y is 0. So that's one of the solutions, 0. And when x equals 7, the y is 0, which means that's our second x-intercept. So the solutions are 0 and 7, which is exactly what we got when we solved the equation by factoring. Now let's take a look at our last example. We have x squared plus 5x plus 6 equal to 0. I'm trying to solve this quadratic for x. That means I need to use factoring to be able to solve this quadratic algebraically. I'm looking at the quadratic, and I can see that I have a trinomial with a leading coefficient of 1. And to be able to factor this trinomial, I need to think of two numbers. If I multiply, I get 6. And if I add, I get 5. The two numbers are 2 and 3. 2 times 3 equals 6. And 2 plus 3 equals 5. So now I have two factors for this trinomial. The first factor is x plus 2, and the second factor is x plus 3 equals to 0. Now that I have two factors multiplied by each other and their product is 0, I can use the zero product property and say that the first factor can be a 0 or the second factor can be a 0 and solve both equations. I'm going to solve the first equation by taking away 2 from both sides, and I'm going to end up with x equals -2. And I'm going to solve the second equation by taking 3 away from both sides, and I'm going to end up with x equals -3. So the solution for this quadratic is, or two solutions, x equals -2 and x equals -3, which are also called the roots, the x-intercepts, and the zeros. And the calculator, we have y equals, this time I'm going to put x squared plus 5x, x squared plus 5x plus 6. And again, I'm going to look at the table to find out what the x-intercepts are. So I'm looking at the table, and I can see that I have two zeros when x is -3 and when x is -2, which are exactly what I got when I solved the quadratic by factoring. We can also find the zeros using the graph as well. So in the graph, as you can see, the graph crossed the x-axis at 2 points, -2 and -3. And the calculator can also calculate the zeros for you if they're not so clear on the graph and in the table. If you go to second trace, number 2 for 0, and then ask the calculator to find one of the zeros. So I'm going to try and find the first zero, which is -2. So I'm going to move my pointer to the left side, since the calculator is asking me for the left side of my 0. And I'm not going to be far away. I'm just going to get close to it, but not very close. So I'm going to choose that point. And then I want to tell the calculator that I need the right 0. So I'm going to move the pointer again to the right side of the first zero, and I'm going to ask the calculator to give me the answer. And the answer is -2. The calculator can also give you the second zero by doing the same thing again, but this time moving the pointer to the left side of the second zero, and then identifying the right side of the second zero. So I'm going to choose that point right here. I'm going to hit enter, and the calculator is going to give me -3, 0. So this is useful when the zeros are not so clear in the table or on the graph, and the calculator can do that for you.